I'll be talking about compaction and auto-compaction in Apache Druid today. So as many of you have used Druid before, you notice that every time you ingest data, it's stored as a segment, and those segments are immutable once they are created. So any subsequent data coming in are created as another segment. To get the optimum performance, you need those segments to be of a reasonable size, and compaction is one way of getting that done. So just a little bit about me. As mentioned, I used to work at Imply Data, and currently I'm with Netflix in the Big Data Compute team. We work on things like Spark, Trino, Druid, obviously. And for myself, I've worked on ingestions, compaction, auto-compaction, and various other Druid system-level features like auto cleanup, auto queue, and things like that. So Apache Druid at Netflix. So we have various Druid cluster at Netflix. An example use case is delivering detailed insights into how our users are experiencing the service. So example, when we deploy new features, we want to be able to, in real time, monitor how that affects user experience, view times, things like that, to make sure that there isn't any degradations in performance or in experience. So we have hundreds of terabytes across hundreds of data sources, thousands of billions of rows in each of our cluster. So jumping back into compaction. So why would you want to use compaction? So as I mentioned before, you might have the problem of the tiny segments or inoptimal segment size. And why would that be the case? So you might have late arriving data coming in. So if you have ingestion streams, you might have data coming in from days ago, and then those will be created as a new segment. You might be appending data. So you set append to existing as true, and you might be backfilling data after the fact that you already ingest data for those days. You want perfect roll-up. So if you use streaming ingestion or you ingest with dynamic partitioning, initially you may not get perfect roll-up. And the next two are about segment size. So you might not already have optimum segment size. You might misconfigure your ingestion tasks. As earlier talks went into things like the max number of segment per task, max number of row per segment, and things like that. You might have misconfigured them initially. So you might not have the optimal segment size, and you need to fix that. You might so the next point is about why using compaction rather than just doing another re-index task or batch index is because for compaction, you don't need to specify all your specs, all your metric spec, dimension specs. If you're not changing any of those, you can just leave them out, and compaction tasks will automatically detect them. The next two are sort of new-ish. So you can also use compaction to change your data partitioning. You can change your granularities, change your partitioning from dynamic to range or to hash and things like that. And then you can also modify your data schema using compaction. So you can remove a dimension, add the metrics, things like that, all with compaction. So now, what is the difference between compaction and auto-compaction? So the first thing is the similar thing between the two is that they override existing data and they help you solve all of those problems in the previous slide. The difference is that compaction task is just a single task. You submit a spec, and then it'll run according to that spec, and it's just a one-off thing. Auto-compaction is more of like a scheduler. So you submit it per a data source. It's a background system that runs in the Druid coordinator. It can create multiple compaction tasks. It's more of like a scheduling. It looks at which intervals need compaction and which intervals already compacted. It determines how many task slots you have allocated to the compaction system. So there's guardrails on resource consumptions. It can retry on failure if a task happens to fail for any reason. It can rerun on changing data. So if you already compacted an interval and then you have late data coming in, and then that interval now is no longer compacted, the auto-compaction system can detect that and rerun on those intervals. And with compaction tasks, you don't get a lot of those stuff. You don't get guardrails or rerun or retry. It's just one single task. You submit it, it either succeed or it failed, and that's the end of it. So I'll go over a little bit on setting up both of those, but the documentation in the Apache Druid website are much more detailed, and I recommend you to check those out if you're trying these things out for the first time. So manual compaction, as mentioned before, are just a single task, similar to how you would submit a batch ingestion task. You have a task spec on the top right. You have things you're familiar with, like IO config, dimension spec, metric specs, tuning configs, all of those stuff. You can submit it through the Druid console or the API directly. For auto-compaction, there's a couple more steps. So the first thing is that you need to set up the capacity for auto-compaction tasks. And there's an API for that. That tells Druid how many task slots is available for auto-compaction to use. And that's calculated from the maximum number of task slots you have in your cluster. So for example, if your middle manager has 5 slots per middle manager, and you have 10 middle managers, you have 50 task slots. So those ratio and those max are calculated from that 50 task slot. So you can allocate, say, 0.5 ratio, and then auto-compaction would only use 25 task slots, for example. Once you set up the capacity, now you can submit an auto-compaction config for each of your data source. So the auto-compaction config is similar to the compaction config, but there's a couple more fields. You can check that out on the documentation. And basically, what it does is it uses what you specified in the spec, like the metric spec, tuning config, dimension specs, and all of those stuff, and then apply that to all of your intervals that isn't compacted yet. And you can do that through, again, the Druid console in the data source tab, or directly through the API. So why use auto-compaction? A lot of people, before auto-compaction exists, has their own workflow outside of Druid to submit a bunch of compaction tasks. It can be things like Airflow, workflow notebooks, or cron jobs, or things like that. And the problem with that is because you won't really get benefit from open source contribution. Every company has their own thing. We're reinventing the wheels. If you're new to Druid, then you have to put in additional work on setting these things up. So that's one of the biggest reasons people should explore auto-compaction. And auto-compaction itself will get you benefit, like you set once and forget, you just set it for a data source, and it will work its way through that data source, making sure intervals are compacted. It automatically retry on failed compaction tasks. So your compaction task might fail if there's a conflict in lock. It will retry, automatically rerun on interval with changed data or schema. So if you have late data coming in with different schema than the one you specify in the auto-compaction, it can rerun on those. It can basically choose interval based on policy. So right now there's only one policy, but we'll go over that a little bit later. It can manage cluster task slot. As in the previous slide, we can set up guardrails on how many task slots it can use. This can ensure that you won't starve your streaming ingestion, which is important because it's real time and those have a higher priority. It can also enforce data source schema. So in Druid, you don't really have the concept of schema per data source. Each segment has its own schema. But what you can do is you can specify a schema in the auto-compaction. So for example, you can list what dimension you want, say dimension A, B, C. And when auto-compaction runs through all of your intervals in your data source, it will make sure that all of those intervals will have when it's recompacted, will only have dimension A, B, C that you listed. So if it has more dimension before you compacted it, after compacted, it will just have A, B, C, for example. So you can enforce a schema on your data source. You will also get compaction statistics, seeing how many segments or intervals are compacted versus not compacted, and you can monitor that progress. So some of a gotcha and pitfall that you might see in setting this thing up. So a lot of people see that their auto-compaction are not running. And one of the reasons might be because of the task slot. You might not have set up the guardrails around capacity correctly, and you might just have 0 slot allocated for auto-compaction. Then in that case, you're not going to get any compaction tasks from auto-compaction. And then the next couple of pitfalls are around configs. So these are configs in the auto-compaction spec that you submit to a data source. The first one I'll talk about is input segment size byte. So this config actually exists for a historical reason. It's telling Druid if the total size of your interval is greater than this config, then it will skip this interval. So before this, auto-compaction only submit compaction tasks that runs in a non-parallel way with no subtasks. So then we limit on the size that you can use auto-compaction on. But now that your auto-compaction can run compaction job as a parallel task, this config isn't really needed, and you can set it to, right now the default has been changed to like max long, but if you're on previous version and you have historical's default, then you might consider increasing this to max value, max long. The next two are about skip offset from latest. So this tells auto-compaction to skip a certain period of time from the latest so that it doesn't conflict with your incoming data that is still coming from ingestion, real-time ingestion. And the skip offset from latest calculates the period from the latest timestamp of your data source, not the latest timestamp of current time. So if your data source only have data up to 2021 and you set skip of 1 month, it will be like 1 month from that 2021, not 1 month from today. So if your skip is too small, you might be having a lot of conflicts with real-time ingestion tasks for data that is still coming in. If your skip is too large, then you might be skipping too much and not getting enough compaction to get the optimal performance. So to set this, you need to know if data is still being ingested and how much late data you expect to get. The next one is max num concurrent subtasks. This enable auto-compaction to submit compaction tasks that can run in parallel. If you set it too low or set it to 1, then your compaction tasks will run for a very long time. And by default, it is set to 1, and that's a lot of pitfall that people haven't changed it. See that the compaction task runs for hours and hours and never complete. So similar to how you would run your batch ingestion, you would set that higher depending on how much data you have in each of your interval. And then the last one is about how often auto-compaction itself runs. By default, it runs every 30 minutes. And a lot of people are saying that auto-compaction doesn't kick off compaction tasks fast enough. So one reason might be that their compaction jobs only run for a couple minutes and they're done, and you have the rest of that 30 minutes of that time, nothing is happening. So you can consider reducing the period that auto-compaction runs. There is 2 ways of doing this. You can set the indexing period, but that will affect all the other duties in the indexing groups. You can find more detailed documentation on that config. And there is a second way, if you follow that link to the docs, you can set the period just for the auto-compaction itself without impacting the period of other indexing jobs in Druid. So the next one is about running auto-compaction at scale. And this is from experience and as well as of the latest release. This might change in the next release when we have the multi-stage query engine. So the first thing we did was we increased the auto-compaction cycle frequency. So we ran it as a separate group and we run it more frequent. This is safe to do because, as mentioned before, there is a guardrails on how many task slot auto-compaction can use. And that guardrails take into account compaction tasks that are already running. So if your max slot is 25 and you already have 10 compaction jobs still running, when the next cycle of auto-compaction kick off, it will take that into consideration and only issue 15 more if you already have 10 and your limit is 25. So you can set that frequency to be more frequent, and it wouldn't, at any point in time, it will not go above your limit of task slots. So we set that to just a couple minutes so that we can have it kick off tasks whenever tasks are done. We also enable auto-scaling of the Druid indexer, the middle manager. And this helps a lot because auto-compaction can be spiky. Like if you enable auto-compaction for the first time for a new data source, you're going to get a lot of compaction jobs. But once it catch up, then you're just only going to get a few compaction jobs every hour, right? So then the auto-scaling helps us save money and deal with changes in the resource consumption. With enabling auto-scaling, we also changed the max compaction task slot to consider auto-scaler slots. So there's, at the end here, use auto-scaler slot equal to true. That instead of just calculating the number of slots from current cluster capability, it considers the maximum number of middle manager that auto-scaler can scale up to and calculate the ratio and the max slot to use from the maximum number of task slot, considering maximum auto-scaling. The next one is, the next two are more about tuning the actual compaction job itself. It requires a little bit knowledge of your middle manager nodes and your data. For the first one, tuning config is similar to how you would tune your batch ingestion, knowing the memory core and things like that on your middle managers you can set up. And the last one is setting up the split and the max number of subtasks. So that deals with the parallel of your compaction tasks. That requires knowing the segment size distribution you have, how large your interval is, and things like that. So those last two are similar to how you would tune your batch ingestion. So next we'll be moving on to more of a things you can look forward to around the compaction and the auto-compaction area. In the short term, there's three main areas. The first area is just performance improvement in both auto-compaction and compaction. Making sure auto-compaction submit tasks faster, more efficiently. Making sure compaction task itself complete faster. And the next area are more of enhancement in auto-compaction. So things like adding new policies. You can choose, instead of just moving from latest interval, you might be able to choose from things like looking at the biggest segment, or like the biggest skewed in your segment distribution, and work and compact those intervals first so that you get maximum benefit. And the last area is integrating auto-compaction and compaction tasks with the multi-stage query engine. The benefit with that comes with the multi-stage query engine is that compaction tasks will finish faster, and you'll be required to do less tuning. So in the Pitfall, we talk a lot about of how you can stab yourself with the configs. With the multi-stage query engine, a lot of those configs will not be as essential. Some of them might some of them you don't even need to tune. So that will help getting compaction running as fast as possible. In the long term, we'll be looking into expanding the capabilities of the auto-compaction system itself. So the first one is creating a concept of a derived data source or a materialized views from auto-compaction. For example, you might have a data source, you ingest it in without any roll-up. And say you want to create a couple of other data sources with some derived from this original data source. So each one might have roll-up turned on with different dimensions. Each one might have different roll-up granularity. Each one might have different amount of data, and all derived from the original data source. So you can use the auto-compaction and set up a different output to create those data source. And as data come into your original data source, they will flow into your data derived A, derived B, derived C data source according to the different schema that you set. And the other one that will be coming soon, or that you can look forward to, is tidying the auto-compaction with similar things to the load rules, drop rules that you're familiar with. So you can set a different schema for each different periods. So similar to load rules where you have latest one data you load onto hot tier, latest 1 day data you load onto hot tiers, and any older data you load into cold tier. You can now apply a different schema. You will be able to apply a different schema to the different loading periods. So in your latest 1 day, you might have a schema where you roll up to hours granularity, and older data, you might have an auto-compaction spec with roll up to month granularity. And auto-compaction will, as data age, will apply compaction job with the different schema so that you can have different granularity, or you can like drop dimensions or apply different schema as it makes sense as your data age. So all of those leverage the power of auto-compaction, where you have a scheduler that can submit a compaction job that modify your schema of the data. And that's it. Thank you so much.